On this page, we have the basic guidelines for deciding what will happen in any of the reactions in both Chapter 6 and Chapter 7. Now, this is for both the substitution or both SN1 or SN2 reactions, and also the eliminations that we'll see in Chapter 7, E1 and E2 reactions. So keep these in mind as you're studying for Test 3. But the first thing we want to think about is the strength of the base or nucleophile determines the order of the reaction. A strong base or a strong nucleophile forces either an E1 or an an E2 or an SN2 reaction. So examples of strong bases, strong nucleophiles are going to be something with a negative charge on it. So like methoxide would be an example of a strong base and a strong nucleophile. A weak base or a weak nucleophile forces either SN1 or E1, and an example of a weak base, weak nucleophile would be methanol, where you have the neutral molecule. The oxygen of the neutral molecule stabilizes both the formation of the cation by having the lone pair around it that can orient towards the positive charge, stabilizing it. So that's the strength of the base or the nucleophile to order what type of reaction it can be. The next thing we need to think about is if you have a primary halide, your only two possibilities are SN2 or E2. It will not do an E1 or a SN1 mechanism in those. So it has to be either a SN2 or an E2. And the difference between the two is an SN2 will happen when you have a good nucleophile that's a strong base, whereas an E2 will happen when you have a bad nucleophile. And the one example of a bad nucleophile is when you have T-butoxide and all of the methyls take up so much space, it's hard for it to do the substitution. It's much easier for it to grab a hydrogen on the outside edge of the molecule and form the double bond. The next one is the tertiary halides, and they're the one that is a little different than everything else because we can do an E2 on it because if we have a strong base, it goes E2 because there's not time to form the cation. Otherwise, if you have a weak base, it's either a E1 or an SN1, and the difference between the two is if you have heat in the reaction, it will end up being an E1 elimination, not a substitution. And then secondary halides, they're kind of can do anything. It all depends on what do we have. If we have a strong base, strong nucleophile, it goes via a 2 mechanism. If we have a weak base, weak nucleophile, that's a good ionizing solvent, water, methanol, any of the alcohols, it goes a 1 mechanism, SN1 or E1. And the difference between the two is if you have heat, it favors elimination. Okay, from our solvents, we can also see what can happen with a polar protic solvent. An SN1 mechanism is preferred because it stabilizes the cations and anions, and examples of this are water, methanol, or ammonia, all things that have a hydrogen on a more electronegative atom, oxygen, nitrogen, okay, where we have hydrogen bonding that can occur. A polar aprotic solvent favors SN2 mechanisms because they only solvate the cations. Since the anion is not free, it raises the energy of the starting materials, making the activation energy lower. And examples of this are DMSO, DMF, HMPA, and ether. Most of the time we'll see ether or THF as our solvent for this. The next one we need to talk about is high temperatures. When you have heat, which you'll normally see as the delta, it favors elimination. And then some bases favor substitution. The small ones, methoxide, favors substitution, whereas big ones favor elimination just because of the steric hindrance involved in the reaction. So here we have the basic sn2 mechanism where the nucleophile comes in and displaces the leaving group. In this, the R groups we're just putting an R group out there. It could be an H, it could be a carbon, it doesn't matter at this point what it is, but the nucleophile comes in and forms a bond to the carbon, and the leaving group leaves all in one step. So when we look at these 7 reactions down here, all we have to do is decide what is the nucleophile and have the nucleophile come in and displace the leaving group and draw out our product. And the mechanism for all 7 of these is going to be exactly the same, where the nucleophile comes in and the leaving group leaves. We just have to decide what is the nucleophile in each one, and we should be able to draw out the Lewis structure for each of the nucleophiles. So, and we have to be careful when we connect things that we connect it to the correct atom so that it all looks good. Okay, and we're not drawing it wrong, like connecting the carbon of the carboxylate to the carbon of that had the leaving group on it. And nitrogen is a really good nucleophile, so the neutral nitrogen can act as a nucleophile displacing the bromide to give us the quaternary ammonium salt. Now, the one thing we haven't talked about is, if you had a stereocenter in an SN2 mechanism, what would happen? We've said the nucleophile comes in, attacks the carbon, kicks out the leaving group, but when that occurs, the charge, remember, the nucleophile is coming in with a negative charge, and the leaving group, when it leaves with a negative charge. So we have, when we draw the transition state for this reaction going on, if it's on methane and we have 3 hydrogens, the nucleophile is coming in with in the transition state, it has a partial negative because it's coming in with a negative charge, and the leaving group is leaving with a negative, so in the transition state it has a partial negative. So we want those negative charges to be on opposite sides of the carbon, so when it comes in, if we have a stereocenter, like down here in the bottom example where bromine is priority 1, the ethyl is priority 2, the methyl is priority 3, and the hydrogen is 4, we have a molecule that is R, and when we look at going through the transition state to the product, we invert the stereocenter, and this product has to be drawn S. So in an SN2 mechanism, if you have a stereocenter, you have to be careful about that and make sure you invert the stereochemistry of the product. And you have to draw it so that it shows that it is S. We can't draw it any other way.